Hello and welcome to part 5 of my series of demystifying data science. In this video, I just want to talk briefly about data processing, and data processing is really the real work behind data science and working with data. In my last video, part 4, we left off with the NumPy package. And if you're interested in learning more about the NumPy package and the operations you can perform using NumPy, I created a 2-part series that covers all the fundamentals of NumPy. So if your curiosity was piqued by what can be done in NumPy, we'll be using that later on as well, but it'd be good to have that foundation. So make sure you check out my code along video series titled Getting Beyond the Basics with NumPy. In this video, we're going to be talking all about data processing and just getting a real good idea of what data processing is. And what I'm about to say is a pretty big statement. And I'll just get to it. Data processing is the most important part of data work, hands down. It's a generally agreed upon consensus that 80% of data workers spend their time cleaning data. It's a huge part of what data analysis, data analytics is, and through that, it's what that means is you really, through the cleaning process, you get to understand the data. You get to see and know what constitutes as good data for the data set that you're working on, and what can be, thrown away, dropped, or what columns can be dropped, what items you don't need, what items you need to bring in. You can merge data sets and bring in new data to kind of understand and gain a better context for that data that you're working with. And so we'll go through an example here of what cleaning data may look like, but just know that this process and the cleaning of data that's the meat and potatoes of data analytics. And through this transformation or normalization process of working with data, that is what is going to lend itself to those performing those accurate aggregations, the manipulations, how you can synthesize your data in some beautiful visualizations that you can present and show and really show and tell the story of the data to others, and then perform machine learning on that data for forecasting and predictions and knowing, identifying trends or what have you, whatever you want to, whatever you're going to end up doing with your data. But it all starts, all that, none of that can be done without the cleaning process, the processing of that data, and through that process you'll be the new master of whatever data you're working with. So I just created this quick and brief example of a transformation. So this is an example data set. Say you're a company that manufactures all these parts, and so the part naming convention looks pretty standardized and uniform. You have they all start with PN, and there's 4 digits after the PN. So part number 1234. So and part number 8989, and so on and so forth. So good uniform data there. And then the part description, you have the name underscore number. That's a great uniform way of classifying that data. Part mass probably could be cleaned up a little bit. You have 3 float values here, and then 3 float values and then 1 integer down here. You can make that call. You'd probably, if I was the one working on this data, I'd probably want to change all those values, that entire column, to float values, just to make sure all those data types are the same. But the real thing that stands out in this data set is the mass type. This is totally crazy, and that's how you're going to get your data. It's not going to be all uniform. So if you were to just graph this out as is right now, this item is going to show. Oh, sorry. This item is going to show up. This part number 9999 is going to show up as the largest item in your data set if you were just to graph that out. But it's actually the smallest item because it's in milligrams. So if I was in charge of cleaning up this data and doing some analysis on this data, I would probably change all these all the part mass types, which means changing all the part. You can't just change all this to grams because you have to do some work here. So do you see the I hope you see the underlying concept. What I mean when I say data processing and cleaning is that you're going to have to do some transformations to some. When you do something on one area, you also have to understand how it affects the entire data set and really get a comprehensive picture as to how you're going to work with that data set. So changing these items to grams is more than just changing this row. You have to do the calculations, and so that's what I really mean by data processing. Other transformation examples are things such as how do you handle the null values in your data set? Which just means empty data. Null value is just an empty. If you're looking at an Excel sheet, one of the values is empty. It would be if we didn't have, for example, the part mass here for this item, that would be a null value if that was just blank. So you'll have to understand and make those critical calls on what values do you drop, what rows or records or columns do you drop, what are necessary, what's necessary for your analysis, because you want to find that efficient balance because you don't want every possible thing in your data set, because then your data set and your machine learning algorithms then become slow. Your processing is slow on your data. So you want to be as efficient as possible, but provide all the context necessary. So that's a hard task, and that's why data science is a real skill. Another thing that you'll have to do is merging and joining and grouping your data sets. So sometimes you'll have multiple data sets that you have to, from various sources, that you have to bring together and merge that data. And then, like I said before, let's skip down here to the last one. Make sure all your data types are the same. Integers, floats, booleans, strings. Integers are just numbers. Floats are numbers with decimals, so more exact numbers. Booleans are true-false values, and strings are text values. And when I say text values rather than letters, is because numbers can also be string values, but they're rendered as text. And we'll dig into that in our next video, and when we start to pull in and play with some real life data set. But all that transformation is going to give way to doing some real calculations, aggregations, manipulations of the data to understand what the standard deviation, the mean, the median, what values are, and to be able to graph that out and perform machine learning on that data. And the data processing package that we're going to use, that is most widely used, is the pandas package. It's the best data processing package for Python. Pandas.org, and I'll show you this in the pandas package, that you can actually pull this quote up in the pandas library, in the pandas package. But its goal is to be the most powerful and flexible open source data analysis and manipulation tool available in any language. And I think they're well on to fulfilling that credo, I guess. And you'll see we'll dig into how powerful pandas is. If you want a really in-depth view of pandas and the pandas package, I created a few part series on pandas and getting beyond the basics with pandas. So please check that out if you're interested in digging deep into pandas. But let's jump into the next video and pull in some real life data and start doing some processing and real manipulation. So we'll see you then.